Good day, learners. Today we are going to discuss equation of a circle. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be updated for my upcoming videos.
Three, two, one, zero.
Uno, dos, tres, cuatro.
In this video lesson, we are going to talk about the equation of the circle, how to find and what are the equation of the circle in standard form. Conic sections. Conic sections are particular type of shape formed by the intersection of a plane and a right circular cone. Depending on the angle between the plane and the cone, four different intersection shapes can be formed. The types of conic sections are circles, parabolas, ellipses, and hyperbolas. So this is now the illustration for the parabola. So when the plane and the cone intersect with each other, and this is now the circle, ellipse, and the hyperbola. Degenerated conic sections are the results when a plane intersects the doubled cone and passes through the apex. Depending on the angle of the place, three types of degenerated conic sections are possible: a point, a line, or two intersecting lines, as shown in the figure below. Circle, parabola, ellipses, and hyperbola are sometimes called non-degenerated conic sections, in contrast to the degenerated conic sections. Circle. Circle is a set of points x and y in a plane that are the same distance r from the point called center, labeled as coordinate h and k, as shown in the illustration below using the distance formula. So this is now our circle. This particular point is the center, so labeled as HK. And this is now the point on a circle labeled as X and Y. And this is now our radius. So as we are going to draw a horizontal and vertical line from the center and the point on a circle to create now a right triangle, and take note that from the point of origin going to the X, this is not the distance. From the point of origin going to the H, this is the distance. And if we are going to subtract now the distance of the X and the distance of the H from the point of the origin, so this is now the side which is labeled as X minus H, and this is now our Y, the distance from the point of origin going to the Y, and this is now our point K, and this is now the distance from the point of origin going to the K, and this is now the distance when we are going to subtract now the distance of the Y by the distance of the K. So the Y minus K and the X minus H, as we are going to relate it to our right triangle that we drawn from the circle, so this side will be our Y minus K and this side will be our X minus H. So as we are going to relate this one to a right triangle, we all know that in solving right triangle, we are going to use now Pythagorean theorem. So this is our hypotenuse labeled as C, and these are the two legs of our right triangle labeled as A and B. So let us now discuss how does the equation of the circle in standard form derive. So from the Pythagorean theorem, so we are going to substitute A be our X minus H, and our B be our Y minus K. So we're going to use we are going to use now the Pythagorean theorem. So we have now a squared plus b squared is equal to c squared. As we are going to substitute now the value for the a, which is x minus h, and the value for the b, which is y minus k. And also, instead of writing c squared, we're going to replace it by r. So this is now our equation of the circle in standard form when the center is located at the point hk. To derive the standard equation of the circle whose center of the circle is located at the point of the origin of the Cartesian coordinate plane, just substitute coordinate hk by 0 and 0 to the above equation, this one. So we have now x minus h squared plus y minus k squared is equal to r squared. So as we are going to substitute the value for our h, which is 0, and our k, which is 0, x minus 0 is x and y minus 0 is y. So we have now x squared plus y squared is equal to r squared. So this is now the standard equation of a circle when the center is located at the point of origin. To sum up now, a point x and y lies on a circle of a radius r and the center hk. So the equation in standard form is x minus h squared plus y minus k squared is equal to r squared. When the center of the circle located at the point of origin, then the equation of the circle in standard form is x squared plus y squared is equal to r squared. Example number 1. What is the equation of the circle in standard form shown below? So this is now the given illustration. This is our circle. The question is, what is the equation of the circle in standard form? So first thing we need to do is we are going to locate where is the center of the circle in the Cartesian coordinate plane. So in this case, by inspection, the center of the circle is located at the point -1 and -3 with a radius of 2 units. So therefore, our coordinate hk will be -1 and -3, and our r is equal to 2. So substituting now the value for the h, which is equal to -1, and the value for our k, which is -3, to our standard equations. So let us now substitute the value for the hk to our equation of the circle in standard form. So we have now x minus h squared plus y minus k squared is equal to r squared. So as we are going to substitute now, it becomes x minus -1 squared plus y minus -3 squared is equal to 2 squared. So as we are going to simplify further, x minus -1 becomes x plus 1, y minus -3 becomes y plus 3. So we can say the equation of the circle in standard form when the center located at hk -1 and -3 having a radius of 2 is square of x plus 1 plus the square of x plus 3 is equal to 4. Example number 2. What is the equation of the circle in standard form shown below? So as what you can see, this is now our illustration, and the center of the circle given is located at the point of the origin. By inspection, the center of the circle is located at the point of origin with a radius of 3 units. So we can say that our hk located at 0, 0 and r is equal to 2. Or if we're going to use now the standard equation of the circle whose center is located at hk, so if we're going to substitute now the value for the h, which is 0, and the value for the k, which is 0 also, so we can say we have now x minus 0 squared plus y minus 0 squared is equal to 3 squared. So as we are going to simplify x minus 0, that is equal to x, and y minus 0, that is equal to y. So we can say x squared plus y squared is equal to 3 squared, or simplifying further, we have now x squared plus y squared is equal to 9. Okay, example number 3. The coordinate 2 and 2 lies on a circle whose center is at the coordinate -1 and 2 as shown at the left. Write the standard form of the equation of the circle. So as we are going to plot now the center, which is -1 and 2, and the x and y, which is a point lies on a circle, which is coordinate 2 and 2. First thing we need to do is find the distance between the point 2 and 2 and -1 and 2. Because if we're going to connect now the 2 point, that will be the radius of the circle. So find the distance between -1 and 2 and coordinate 2 and 2 using the standard equation of the circle to get the radius of this circle. So our HK, which is the center, is coordinate -1 and 2. Our x and y is 2 and 2. Solve for the radius. So this is now the equation of the circle in standard form, whose center is located at HK. So substituting the value for the x is 2, h is -1, y is 2, and k is 2. So we have now 2 minus -1 squared plus 2 minus 2 squared is equal to r squared. So as we are going to simplify further, 2 minus -1, that is 2 plus 1, 2 minus 2 copy. Then 2 plus 1 is 3, we have now 3 squared. 2 minus 2, that is 0, so we have now 2 minus 2 is equal to 0, so that is why we have now 0 squared is equal to r squared. So as we are going to simplify further, that is r squared is equal to 9. But we have to omit now the square of the radius by extracting square root both sides. So we have now r is equal to 3. Remember that radius is always positive. Though if we're going to get now the square root of 9, that is positive -3. But since we're talking about radius, we're going to disregard the -3. So we're going to get now positive 3. So for our radius. So our r is 3. So to find now the standard equation of the circle, given in the problem, so HK, we all know that HK is -1 and 2. Then we already computed the value for the r, which is equal to 3. And substitute it to the standard equation of the circle. So this is now the equation of the circle in standard form. Substituting the value for the r, the h, and the k. So we have now x minus -1 squared plus y minus 2 squared is equal to 3 squared. So simplifying further, so x minus -1, that is x plus 1. Then 3 squared is equal to 9. So we can say that the standard equation of the circle in the given problem is the square of x plus 1 plus the square of y minus 2 is equal to 9. So this is now the standard equation of the circle. Example number 4. What is the equation of the circle in standard form whose center is located at the point of origin and passes through the point 3 and square root of 7? So this is now the graph. Find the distance between point 3 and square root of 7 and the point of origin using the distance formula or the standard equation of the circle to get the radius of the circle. So our HK is 0, 0. Our x and y is 3 square root of 7. So let us now solve for the radius. So x minus h squared plus y minus k squared is equal to r squared. Substituting the value for the x and the y and the h and the k. So we have now 3 minus 0 squared plus square root of 7 minus 0 squared is equal to r squared. So 3 minus 0 is equal to 3. Square root of 7 minus 0 is equal to square root of 7. Then we can say 3 squared plus The square root of 7 is equal to r squared. Simplifying further, we have now square root of 3 is 9. Square root of 7 is equal to 7. So 9 plus 7 is 16. Then extract square root both sides to meet now the exponent 2 of the radius. So r now is equal to 4. So substitute the value for the hk, which is now 0 and 0, and the r, which is equal to 4, to the standard equation of the circle. So x minus h squared plus y minus k squared is equal to r squared. So we have now, as we are going to substitute the value for the h and the k, so we have now x minus 0 squared plus y minus 0 squared is equal to 4 squared. So we can say that the standard equation of the circle in the given problem is x squared plus y squared is equal to 16. Example number 5. Find the equation of the circle whose center is at the origin and tangent to the line 3x plus 2y is equal to 12. So solution, the radius of the circle is the directed distance from the line 3x plus 2y is equal to 12 given in standard form of linear equation ax plus by is equal to c to the center of the circle at 0, 0. So use the directed distance from a point to a line formula to find the radius. So this is now the directed distance formula from a point to a line. So radius is equal to the absolute value of ax sub 1 plus by sub 1 plus c divided by the square root of a squared plus b squared. So transform the equation of a line in general form ax plus by plus c is equal to 0. Thus, the given equation 3x plus 2y is equal to 12 becomes 3x plus 2y minus 12 is equal to 0. We can say that our a is 3, our b is 2, and our c is negative 12. And the given point whose the point of the origin is our x sub 1 and the y sub 1, which is 0 and 0, and substitute it to the directed distance formula above. So when we are going to substitute the value for the a, which is 3, and our x sub 1, which is 0, plus our b is 2, our y sub 1 is equal to 0, plus our c is negative 12. Divided by the square root of our a is 3, that is 3 squared, our b is 2, that is 2 squared. So as we are going to simplify further, 3 times 0 is 0, 2 times 0 is 0, then copy negative 12. Divided by the square root of 9 plus 4. Simplifying further, we have now square root of negative 12 divided by the square root of 13. So since that is absolute of negative 12, so absolute of negative 12 is positive 12. So our r now is 12 over square root of 3. Since the denominator is a radical, so we can now rationalize the denominator. So shortcut method, the radical must be multiplied to the numerator 12. So square root of 13 times 12, that is 12 square root of 13. Then the radicand, which is the number inside the radical symbol, just copy it and put it in the denominator. So we can say that our radius is 12 over square root of 13, or 12 square root of 13 divided by 13. Next is step is, this is now the illustration. So this is now our line described by the equation 3x plus 2y is equal to 12. And this is our circle at the point of origin whose radius is 12 over square root of 13. So let us now identify what is the equation of this particular circle as described in example number 5. So what we are going to do is we are going to substitute the value for the r, which is 12 over square root of 13, to the standard equation of a circle whose center is at the point of origin. We all know that when the center of the circle located at the point of origin, we are going to use this formula. x squared plus y squared is equal to r squared. All we need to do is we are going to substitute the value for r, since we already computed the value for the r, which is 12 over square root of 13. So we have now x squared plus y squared is equal to the square of 12 over square root of 13. So as we are going to simplify now this one, the square of 12 is 144, and the square of square root of 13, that is 13. Then we can say that the equation of the circle in standard form as described in example number 5 is equal to x squared plus y squared is equal to 144 over 13. Example number 6, a sprinkle water circular area that has a diameter of 20 feet. The sprinkler is located at 25 feet north of the house. If the house is located at the point of origin, what is the equation of the circle of area that is watered? So as we are going to picture out the illustration in the problem, so the house is located at the point of origin, and then the sprinkled water is located at the north 25 feet. So we are going to consider that every unit is 5 units, okay, in the graph to visualize. So this is now the location of the sprinkler. Okay, so the question is, if the diameter of the sprinkled water is 20 feet, what is now the equation of the circle that formed? So solution, the center of the equation of the sprinkler is located at the coordinate 0 and 25, and the radius is, since now the diameter is 20 feet, we need to get now half of 20 feet, that is 10 feet. So we are going to use now the standard equation of the circle whose center is located at hk, and we have to substitute the value for the h, which is 0, and the k, which is 25, and also the radius, which is 10 feet. So the equation now is x minus 0 squared plus y minus 25 squared is equal to 10 squared. So as we are going to simplify further, x minus 0, that is equal to x, so we have now x squared, then y minus 25 squared, copy, and then 10 squared is equal to 100. Then we can say that the equation of the circle of the watered area is x squared plus the square of y minus 25 is equal to 100. And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.